Okay, let's solve one more problem in this. It is given that a vector plus b vector plus c vector is equal to null vector. The magnitude of a vector and b vector are same, which is 1 by root 2 times of the magnitude of c vector. Now they are asking you what is the angle between the vectors. What is the angle between a vector, b vector? What is the angle between b vector, c vector? And what is it between c vector and a vector? Okay, so spend a minute in this problem and get your answers. So basically it's given that a vector, b vector, c vector, the sum of these three vectors is 0. So you must think in line of polygon law of vector addition. The conclusion which we drew just a moment back, if three vectors, the summation is 0, then those three vectors must form the sides of a closed polygon. So these three vectors must be forming the sides of closed polygon. In this case, it would be a triangle because there are three vectors. Now, magnitude of a vector and b vector are same. So let me draw randomly just a vector, a vector. Now, a vector and the magnitude of b vector are same. So maybe we can draw two vectors like this, a vector and b vector, and c vector has a root 2 times the magnitude of a and b, and that will fit very well if you make c vector as the hypotenuse. That comes from Pythagoras theorem, so you can figure it out easily. But the important thing is the direction of c vector. The vectors have to be in the same sense, so you're going in the same sense. In this case, I have drawn it clockwise, anti-clockwise. You could draw it clockwise as well, but it has to form a closed polygon like this. From the polygon law of vector addition, it comes. This, and if I have drawn it like this, that means a vector plus b vector plus c vector is a null vector. So that both conditions are fulfilled, and the magnitude are fulfilled as well because we have drawn a right angle triangle like this. So I'm sure you must have also drawn a right angle triangle like this. Now the question was, what is the angle between a vector and b vector? Now the angle, for angle we have done before that we have to bring vectors tail to tail or head to head. Now if I bring vector a and b tail to tail like this, then the angle which we can see is 90 degree. So the angle between a and b is 90 degree. Angle between b and c, again we have to bring vector b and vector c tail to tail or head to head. Now in this case, if we extend vector b like this, then vector b and vector c, they will come tail to tail, and the angle evidently is 135 degree because this is 45 degree because it's an isosceles triangle. And similarly, the angle between vector c and a will very easily come out as 135 degree again. So must be easy for you, it was just for revision. Okay, so now we are heading towards the last portion of the theory of vector addition, in which we will see the subtraction of vector. Subtraction of vector, basically we see it as suppose vector A and vector B. We have to subtract these two vectors. Now up till now we have done the summation of the vectors, and we have learned the triangular law of vector addition, parallelogram law of vector addition, and polygon law of vector addition, and we have also seen the mathematical formula for the magnitude of the resultant vector and the angle of the resultant vector with one of the vector. That's fine, but we haven't seen the subtraction of the vector addition for the simple reason that it's pretty much the addition of the vector. We look at this a vector minus b vector as a vector, the summation of a vector, and minus b vector. So if we do that, we are back to square one. It's actually just the addition of the vector. Now on a number line, if you see, suppose on a number line, if we have to locate 2 unit on x-axis, we do it like this. If we have to locate minus 2 unit, now minus 2 is just on the opposite side of 2. So it is symmetrical with respect to origin. Similarly, if I have to place 3 unit on y-axis, we place it like this, and minus 3 on y-axis is just on the opposite side. It is symmetrical with respect to origin. Similarly, if we have to locate 2, 3 on the xy plane, we locate it like this, 2, 3. Now minus 2, minus 3 is located here. minus 2 comma minus 3. Now it is symmetrical with respect to origin. The point I'm trying to make is, when we go for a negative of a number, it's just opposite. It's diametrically opposite to origin. It is in symmetry with respect to origin. So if we are having a b vector somewhere, if suppose I have drawn b vector like this, then minus b vector would be just opposite to b vector. If b vector we draw like this, then minus b vector would be drawn like this. On the xy plane, if we draw b vector like this, then minus b vector would be just opposite and symmetric with respect to origin. So this is minus b vector. Okay, so we'll use this fact. Now, let us assume two vectors, a vector and b vector. Let me take this as a vector and this as b vector. Now, for the addition, we have seen the maths, how we do it, and we have got the result that the resultant vector is equal to a square plus 2ab cos theta plus b square, and the angle which the resultant vector makes with vector a is b sin theta upon the tan of that angle is b sin theta upon a plus b cos theta. Fine. So this working we have done before, and you also have practiced this, so you know this very well. Now this was for a vector plus b vector. Now if we are looking for a vector plus a vector minus b vector, that is a vector plus minus b vector. This is b vector. Now just opposite to this must be minus b vector. This is minus b vector. Now if we are looking for a vector minus b vector, what we have to do is a vector plus minus b vector. The summation of a vector and minus b vector is actually a vector minus b vector. So we have to do the sum of a vector and minus b vector. Now when we do the sum of a vector and b vector, we have seen that this is the formula for resultant vector. A vector magnitude of a square of magnitude of a vector plus 2ab cos theta plus square of magnitude of b vector. Now theta is the angle between the vector. Now when we are doing the subtraction of a vector and b vector, basically we are adding these two vectors. Now addition of these two vectors will have the same formula of addition of any two vectors. But the point is, this theta is the angle between the vector. And suppose the angle between a vector and b vector is theta, it is known that the angle between a vector and b vector is theta. Then this actually we just have extended this line backward in the opposite sense. So this is a straight line. So this is theta, then the angle between a vector and minus b vector is 180 degree minus theta. Linear pair. Okay, now if we are doing the summation of a vector and minus b vector, then we have to use the same formula for resultant vector of the addition of vector that we have done. So it will be a square plus 2a magnitude of minus b. See, minus is just a sign. The magnitude will be b. The magnitude will remain the same. The magnitude won't change by reversing the vector. So magnitude is still b. And cos of angle between the vectors. Angle between the vector this time is 180 degree minus theta if theta is the angle between a vector and b vector. Plus b square. So basically it becomes, now you must know by now, if you don't know, it's not a worry, don't worry, you will know eventually. As you live more, as you learn more maths, somebody will teach you that cos 180 degree minus theta is minus cos theta. They may teach you like this, cos pi minus theta is minus cos theta. Pi is basically in radian, pi radian is 180 degree. So both are correct. Either you say cos 180 degree minus theta is minus cos theta, or cos pi minus theta is minus cos theta. When you take this pi, then this angle is also in radian. Everything would be in radian. When you take 180 degree, this theta will be in degree. Everything will be in degree. So that uniformity has to be there. Okay, so this is cos 180 degree minus theta, so it is minus cos theta. And parallel to this, I must tell you that sine 180 degree minus theta is sine theta. It's not minus sine theta. Sine theta, 180 degree minus theta is same as sine theta. Now, so this becomes root over a squared plus 2a minus 2ab cos theta plus b squared. So the formula for subtraction, the magnitude of the mod of a vector minus b vector is this. You have to understand this very well so that you don't do mistakes later on. This theta is the angle between a vector and b vector. And this formula is for a vector mod of a vector minus b vector, when theta is the angle between a vector and b vector. Similarly, if you're looking for the angle phi, which this vector makes with a vector. Now, there will be a resultant vector somewhere here like this. Now, that resultant vector will make some angle with a vector. Now, this is the formula of the resultant vector, the tan of angle which the resultant vector makes with a vector. This is the formula for that. Now, in this formula, theta is the angle between the two vectors in question. Now, if there is this a vector and b vector like this, then the theta is the angle between a vector and b vector. But here we are interested in the resultant of a vector and minus b vector. So you just have to change the angle. The angle would be, instead of theta, 180 degree minus theta, because that is the angle between the two vectors in question this time. So when you are looking for a vector minus b vector, then tan phi, you just have to replace theta by 180 degree minus theta, and sine 180 degree minus theta is just sine theta. So numerator will be as it is. Cos 180 degree minus theta is minus cos theta. So denominator will just, there will be a change of sign. So what we have now is vector A minus vector B, the mod of that, the magnitude of the resultant vector of vector A minus vector B is a squared minus 2ab cos theta plus b squared, if theta is the angle between a vector and b vector, and the angle, the tan of the angle which the resultant vector makes with a vector is sine b sine theta upon a minus b cos theta, if theta is the angle between a vector and b vector. So basically, subtraction of two vectors, we see it as summation of two vectors, summation of a vector and the negative of b vector. And the formulas still will remain the same. You just have to change a sign with cos theta, because cos actually changes sign in second quadrant. So 180 degree minus theta, cos of 180 degree minus theta is minus cos theta. So there will be one sign change here and there will be one sign change here. Rest of the two formulas will remain the same. So that completes the theory for vector addition. And to concretize the concepts that we have studied up till now, we'll now have a tutorial session in which I'll be giving you problems and you must sit with a pen and paper to solve them. And then we'll have a little bit of more of vector multiplication. We have done addition and subtraction. With vector multiplication will complete the theory of vector. But we have done, we are halfway down, and whatever we have studied up till now, let's concretize that by solving some problems.